This is the code for Magic Wand gesture recognition project. It has different pieces to it. One is the train part for training the Magic Wand for the given chipset and the IMU sensor. So different IMU sensors will need different calibrations. So we have trained the device using the collected data. We have collected the data using the Arduino IDE. In this Arduino IDE, we have this tools and serial monitor. So once the device is connected to Arduino Nano, it will basically open that serial monitor, and it will show the information from the BLE sense. So by collecting the data through that way, we have trained the new model or retrained the model. And as we can see, this particular model has different types to it. So first of all, the model is in the floating point format, then we will quantize the model, and then we will convert it into the row format, because Arduino Nano takes only the .cc file for uploading the model. As we can see, this particular project is basically using the strokes that this particular magic wand has drawn in the serial port, and it is taking that as image. And after taking the data, it is explained in the project report in lot of detail how gyroscope and accelerometer and magnetometer convert these particular 3D to 2D image, and how this image is finally generated and passed in as an input to the model. Here we are rasterizing the strokes, and after the rasterization step, we are checking that model is still, the image is almost like, you can see this is the effect of the rasterization, and but it is still possible to pretty clearly see that it is number 4. And once we have that, then we are saving it as image, and we are passing this to the model. Like we can see, we have here the image data set, and we are loading it, and these are the images in the data set. And then we are basically taking this model. This is a convolution model, a very simple model with a few dropout layers and ReLU and softmax activation functions. And then we have basically created this model, which is still in the floating point zone, and here we are showing how the model looks like. It is also doing the batch normalization, and it is a very small model for this task, because on the Arduino Nano we don't have that much memory to put complex and big models, so we have optimized everything. Here we are loading the previous checkpoint of the saved checkpoint for the model, and we are checking the accuracy for this, and then we are trying to predict the image and the accuracy score, and we are going to pick the image with the highest score, to basically say that it is number 4 or what, based on whatever has the highest accuracy. In this part of the code, we are quantizing the model, and then we are making the predictions with the quantized model, and again checking if there is any drop in the accuracy or not. If we would have seen accuracy drop, then we would have used the PTQ or post training quantization, but because this model worked well, so we did not have to do that. Then we are checking that the size of the model is quite a bit changed, so basically it has reduced quite a bit, as we can see here after quantization, and this model is ready to be deployed. But we have to perform just one last step, because Arduino Nano will take only .cc file, so we are converting it to a .cc file here, and then we are going to just save this and basically print it, and this entire print will go in the file that we have already uploaded in the GitHub. So this is our train model, and here in this file, as we can see, so we have this particular model pasted here, and this is our model for Magic Wand project, and this is our rasterized stroke file for basically converting the strokes in the rasterized format, so that the amount of processing required is reduced significantly. This is our rasterization job. And then this is our INO. So basically this particular file is open in Arduino Nano to upload the model, and this is how this particular file is working with the gestures. Thank you.